Molecular geometry. Chemical bonds play a vital role in following the way molecule reacts, as it is related to the geometry of the molecules. I'm Professor Dr. Mchem from Dr. Mchem Institute of Chemistry, University of St. Jamshedpur. And I'm here again today with a very interesting topic which you would love to share. You would love to hear and share among your friends, and you will feel, boost up again as it is going to re-memorize few things which you have just forgotten. Okay, so let's talk about the thing that I just mentioned. Well, how the chemical bonds they of course play a very vital role in following the types of the reactions we normally come across in our chemistry. So they are also important as it makes it easier to follow the reactivity of different chemicals, that is reactants, right? For example, let's take an example of HCl. Its structure is understandable by the bond length, which is an area between the centers of the connected nuclei, right? The connected nuclei, the area, it is this, what is where it is? That is the area between the centers of the connected nuclei. Okay, so it is represented by angstroms. Now 1 angstrom equals to 10 raised to power minus 10 meters, which is again equals to 10 raised to power minus 8 centimeters, which is again equals to 10 raised to power which is equals to 100 pm, that is picometers. Okay, now the bond length of HCl is almost 1.274 angstroms. And a molecule having multiple atoms, to get to know its structure more accurately, we need to know the bond angle. That is, okay, the bond angle too. So along with the bond length, bond angle also is the angle between more than 2 atoms, right? That is the 2 atoms that are there, that is the angle that is formed between them, okay, across any bonds, right? And for example, you can take an example of a methane molecule. I can show you the picture of a methane molecule. Okay, now, so this is a structure of a methane molecule, carbon with 4 hydrogen atoms around, right? So now it can be easily explained if it is, if the carbon hydrogen, that is this one, carbon hydrogen bond length and HCH bond angle are fully known. They can be easily explained, right? The bond length and the bond angle, HCH bond angle and the CH bond length. So now we have learned the 2 terms, the bond length and the bond angles we are talking about right now. So let's talk about bond length first. Now let's understand some points regarding the bond length. Now bond length rises towards zeros, that is the higher periods of the periodic table. Now I will show you a figure, right, in which you are going to see a hydrogen sulfide bond which is longer as compared to the rest of the bonds that are bonded to the hydrogen atoms. Now I have drawn these molecules for you people. For example, of methane, water, methane, yes, then water, then this this one ammonia, right, ammonia, and of course the hydrogen sulfide, right, which I wanted to show, the hydrogen sulfide bond. Now here you can simply see that the rest of the bonds to hydrogen sulfide are not that longer as compared to this one, the hydrogen sulfide bond. This one is the longest of all the bonds that are connected to hydrogen, right? So whereas why is it so? Or you can simply say that where the oxygen or nitrogen or oxygen or sulfur, hydrogen are found in the second period, right? Whereas same with the case with the carbon fluorine bond, right? Where carbon fluorine bond is longer than the carbon hydrogen bonds. All these points out to the atomic sizes, bond length, simply describes the distance between centers of the atoms that are bonded, and larger bonds are formed of larger atoms. Okay, this is something very interesting to share, that larger bonds are formed by larger atoms. So bond length also lessen, reduce, or drop with the increase in the bond order. Now what is bond order? Another new term. Bond order is the number of covalent bonds shared between any two atoms. The number of covalent bonds that are shared between any two atoms is called a bond order, right? Now here I wanted to make few things clear, which I just mentioned it before, that methane has a bond length of carbon-hydrogen bond length of, in angstrom units of about 1.091 angstroms, right? Whereas this ammonia has a bond length between nitrogen and hydrogen equals to 1.008 angstrom, whereas water has 0.958 angstroms, and of course the hydrogen sulfide, which I just mentioned, which is the longest bond, right? This one is the longest bond, so it has got 1.346 degrees angstrom, right? So this is the longest bond, and I explained you the reason why it is as sulfur is in the third period of the periodic table, whereas the rest of these nitrogen, carbon, and oxygen are found in the second period. They are not in the third period, they are in the second period. Same is the case with the carbon fluorine bond, which is longer than, of course, the carbon hydrogen bonds, right? So this was ours. Now let's talk about the bond order, which I just mentioned. That bond order is nothing, that is the number of covalent bonds shared between any two atoms. That is called a bond order, right? So the bond order of carbon to carbon single bond is 1, whereas the carbon to carbon double bond is 2, and carbon to carbon triple bond, that is multiple, the carbon to carbon triple bond is 3. Right, so the reduction of bond length with increase in the bond order is shown in this figure now. Right, now I have another figure here. This is it. So this is another figure of ethane molecule, ethylene molecule, and of course the acetylene molecule. That is the single bond, double bond, and the third bond. And I have made these 3D drawings in which you can see a wedged line. Okay, now so here in this figure you can simply see the reduction of bond length with the increase in the bond order. Okay, simply that is the single bond, the double bond, and the third triple bond. Okay, so here I've also written also that simply the effect of bond order on bond length, that is the carbon-carbon bond order increases. It always increases. The bond order increases. Okay, how and when the bond length decreases. When the length of the bond decreases, here you can simply see when the length of the bond is decreasing, which has the lowest value here, right, 1.203, right, that is the acetylene. So it proves this thing, that is as the bond order increases, the bond length decreases between carbon to carbon bonds, right? So this is what is happening here simply in this figure. So now this bond length of carbon-carbon bonds are in the sequence of carbon to carbon bond is greater than carbon to carbon double bond, and is again greater than carbon to carbon triple bond. Whereas moving towards higher atomic number, the bonds of this order decreases in length, right? They always decrease in their length as simply the atoms are on the right side of the periodic table in that particular row are smaller, and differences in size of the atoms, right? So this also thing is very important to note down. Now I hope you find this video interesting today, because today you have learned few things, that is how about the molecular geometry, that is how chemical bonds play a very vital role, a very important role in following a way molecule reacts. the way it behaves, right? And it is also related to the geometry of the molecules. It just simply depends on the geometry, how they are arranged geometrically. Okay. And of course it makes it easier, or it is very important, and it makes it easier to follow the chemical reactivity. For example, I have given you the example of hydrogen chloride in the beginning, hydrogen chloride bond, and its structure, and why it is understandable, and what bond length plays the role in its structure, and of course the area between the centers of the connected nuclei, what it is called, right? So you have learned few different terms today, which I think were forgotten by you many times ago. That is bond angle, bond length, and things like that. So I hope you find that it will re-memorize the things which you have forgotten, and it will again they again got back to your mind, and now you will again start learning. I mean, you will turn the pages of the book and you will start learning the things which you have forgotten, and you know that you know them, but sometimes things are there, and we believe that things are there in our mind, and we will be able to answer each and every question easily. But when we try to ask ourselves all alone, right, not in confronting any teacher, if we are all alone and we ask each from us, we feel like that we are not responding the way we are supposed to be respond. Okay, we are not responding that way to satisfy our examiners with different examples. So I think that we must revise all the things that were being learned years ago, and which we think are no more that much important, but of course they play a very important and vital role in the basics of organic chemistry. So these things are all, they are the building blocks of organic chemistry, and you won't be able to climb that ladder without going through all these basic terms and basic topics which I have started now, so that will enable you, because these things I have just started on request of my few students who were not following the things that were being explained in different books that were being assigned to them by different teachers in our institute. So I thought that I should make few things more clear and easier for them to understand, and they should go for the now after this my lecture, you must go through different books, and you must go through Solomon's, you must go through Loudon, you must go through there are many other number of good books which you can consult. Won't refer you any national level book. I would like to refer you all the books that are written by English authors, and that would be, I think, more appropriate, because you are going to find all the stuff updated and up to a standard. So that is also, and authentic also, because authenticity is everything. So I hope you find this video interesting. You will share, you will like it, you will learn from it, you will understand few points from it, and you will try to memorize the things that I have explained with these examples of these small simple molecules I have drawn: methane, ammonia, and this simply this ethylene, ethane, and acetylene, showing you the three different bonds, that is the single bond, double bond, and the triple bond. So I hope you will like this thing, and you will find your teacher Dr. Moina with something very simple to explain, after going through after making you understand the XRD analysis and the instrumentation regarding XRD and everything. And then of course I now jump back to the only the first pages of the books, so that you can be familiar. On your request, I'm doing all this, so I hope you will like it, and you will definitely learn from it. You will gain few points from it. Hope to see you. I wish you a very good luck for your exam. Wish you a very nice future ahead. Good luck. Thank you.